Hello, hello. I think this is working now. Had some issues with YouTube there. It's been a while since I've streamed last, so I don't know. Needed to update some stuff. Let's see if this works. Yes. Okay. Okay, no, it's not working on all the platforms. Both Twitch and YouTube are looking frozen for some reason. Maybe I need to quit some stuff on the streaming machine. Just a second. Why is Steam open anyway? Okay, I think that may have fixed it. Yeah, at least for me, Twitch and YouTube now seem to be working. Okay, let's try this again. So, hello and welcome to another Polo Sound stream. And also happy Pride. I didn't go to the parade today because I slept through it, but that's life. Also some other reasons, but I have my beautiful flag here and also my Porygon for obvious reasons. Yeah, there's been quite a lot of stuff happening. We went to Hanko to do Hibernation, which is our kind of installation art piece with some performance elements about archives of trance memories and dreams. It was a big success and we're doing more of that for Anti-Festival in a couple of months. Then I bought a new computer, new meaning a 2012 Mac Pro, which is sitting over there. I'm not gonna show it because it's heavy, but yeah, it doesn't work, it doesn't power on, and I knew that when buying it, but I'm hoping to fix it once I have some time for that. But the actual topic of today's stream, it's actually only 2 in the afternoon here. The actual topic is this MIDI controller here. And this is a Novation Nocturne. from I think 2008. I bought it around then, and then I've had it for a while. It's not a bad controller per se, except for the fact that this actually isn't class compliant MIDI. Instead, this communicates with a program on the computer made by Novation called AutoMap, and they have their own protocol for that communication. And then AutoMap in turn creates like a virtual MIDI device on the computer, and then that's what you use to send MIDI to your DAW, or in my case probably Super Collider or whatever you have. So yeah, the thing about AutoMap is that it was never a very good piece of software. There's some really annoying things about it. It does try to do some fancy stuff aside from just sending basic MIDI data. There's also a feature in it where it like somehow it lets you automatically map your controls to VST plugins or something, and then you just, well, I guess that's why it's called AutoMap. Yeah, then you just have your controls mapped in some sensible way. So I guess they had like a big database of VSTs which they would then detect from, and then choose some reasonable mapping for that, and yeah, whatever. I never actually used that, I just used this as a normal MIDI controller. And I would like to keep doing that, but the problem is that AutoMap is now abandonware pretty much. It hasn't been updated in years. The last version of macOS that it runs on is 10.14, which luckily is what I still happen to be running, although I need to upgrade very soon. But it's a very good time for me to be looking into this while I still have this OS. Because what I want to do is basically reverse engineer the protocol and write my own driver, although it'll be a user space driver, so yeah, an app you run and then it sends MIDI or OSC. Yeah. And I've actually done quite a bit of work on that already. So, well, okay, this is maybe getting ahead of myself. Let's switch to this other computer where I have Wireshark. And Wireshark is an app for capturing network traffic, but it can also do USB traffic. So with this, I can analyze the traffic coming in and going out of AutoMap. And the reason I have it running on another computer is because the USB interface in my, the USB host controller interface in my main desktop is somehow not compatible with Wireshark, and it gives like bogus messages with no real data. So I have to run this on my laptop, which has like a USB 3 controller, and I guess that is better supported. Or then the other one is broken for a host of possible other reasons. But yeah, I've done quite a bit of analysis already, but let me just show you how you would actually use this. So, okay, let's clear this session so we start from scratch. I would go ahead and plug the USB cable in, and immediately we see some stuff done by the OS. So it gets some descriptors from the USB device, and I guess uses that to figure out at a very basic level what kind of device this is. But the real interesting stuff starts to happen when we start up AutoMap server. So now we can see that the LEDs have turned on the controller here. We have LEDs for each of the knobs, and for the buttons when they're toggled. Then the bottom row here is like special buttons, so you can change pages and toggle the AutoMap window, which you'll see here. So if I press the view button on the controller, this window pops up and disappears. And yeah, you get here also like a view of the state of the controls. And then there's a crossfader, which is fun. You don't get that on very many MIDI controllers, I think. Also, a fun thing about this is that when you map these, there's a feature that if I just lightly touch any of the controls, it switches to that one for mapping. So these controls have like probably capacitive touch sensors, and that's how it does this. And AutoMap, I don't think it lets you use this touch data for anything besides this mapping feature here. Also, I think the last one is broken, the last knob, because it doesn't activate when I touch it. Though I can move it and then, yeah, get the thing. But on the other ones, yeah, I can just lightly touch these and it'll offer me that one for mapping. But yeah, so the idea is to write my own driver for this and basically expose all this data. Sorry. Expose all this data in a raw form so that I can just get, you know, all this data, including the touch, into SuperGlider or whatever, and then handle that however I want. So I had this idea of doing like a touch-sensitive keyboard with these. Yeah, we only got 7 knobs to do that with, but I mean, it could work for something. And also, these bottom buttons here, the bottom row, that are like special buttons, they aren't actually anything special on like hardware level or even in the microcontroller that, you know, reads them on the device itself, because all of these get sent the same way as like a on and off press to the AutoMap software. And it's also possible to set these LEDs totally independently, so even though normally you can just have one page active here, if we write our own driver, we can map these to anything and, yeah, don't have to care about the labels here on the device. But yeah, so here we can see, if I clear this again, or I don't even have to clear it, I can just touch something. Let's say I touch knob 1, then we get like oh, this doesn't line wrap properly. Yeah, so we get, well, there's like a header here for every message, which is like the first, I guess, 32 bytes, so we don't really need to care about that too much. But then here we can see the actual data. So we get a B0 always, and then the controller number 60, and then either 7F, which is 127, or the maximum value for a MIDI control, or a CC control rather. So that's indicating whether it's on or off. So, oh, and I'm not showing the screen. Here we go. So maybe I talked about this before, but I should have like a counter for every time I talk about something and have the wrong view visible, because it happens a lot. But yeah. Okay, so what I was saying is that the first 32 bytes here are the header, the first 2 rows, and then here's the actual data, which is B0, 60 for touching knob 1, and 0 for releasing it, and then if instead I keep pressing it, then, well, like the press event is the 7F here. And when I release, then it's 0. And if I do the same for knob 2, or actually knob 1 if we're going by 0-byte indexing, that kind of makes more sense because these also start from 6-0. But yeah, then here we see that now it's 6-1 instead of 6-0. And so on. Then if I turn the knob, the number is 4-0 instead of 6-0, and so on. And these are actually encoders, so these only send like increment and decrement messages, and then it's the automap software that's responsible for keeping an internal counter for that and, you know, creating the actual value that we see here, and then it sends back the value, which is what causes the LED to light up here to display the value. And we can see that here in the URB interrupt out message. So here we have 40, it's the same number as the incoming event, and then 64, I guess. Yeah, and 4E is decreasing because I keep decreasing the knob. And interestingly, although it makes sense, these are not sent out for every event. It seems it's sending them only when it knows that the number of LEDs that are lit up needs to change, which is smart because then you're not spamming it with useless messages. And for buttons we have a control number starting from 70 and again 7F or 00, depending on whether it was pressed or released. And again, similarly, we have the outgoing message, which is setting the LED. And as with the knobs, the automap software is what keeps track of the toggle states of each button. So we could have these be momentary buttons if we write our own driver. And yeah, I guess just to show that the bottom row of buttons is the same, I'll press bottom row button number 3, and we get a control number of 7A, which is 70 plus 10, and yeah. So these buttons are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we have one more knob here that's called the speed dial. That one, I think, doesn't have touch sensitivity by design. This is for like... I think it's for like scrolling through stuff in various contexts. I seem to remember I used this controller for Tractor way back in the day, the DJ software, and with the speed dial I was able to scroll through songs, I think. But yeah, that kind of stuff. So it's like an extra knob for special features. But we can see that it's just another knob for either sending increment or decrement messages. So decrement is 7F and increment is 01. Oh, also, you can press it. I just realized that. Okay, so that's a control number 51 or 51. I need to keep that in mind because I had totally forgotten about that. And as a final control, we have the crossfader or X-fader, which sounds a lot cooler. This one is a bit interesting because it seems to be sending two messages. So, okay, B0 I think is some kind of general start byte. So B0 is, for example, the very first byte that Automap sends to the controller when it connects. I'm not sure exactly about the meaning of it and when exactly you need it, but in this case, this is a bit weird because we're getting... It's like two messages, both starting with B0, and then we have 48 and 49 control numbers, and then we get their corresponding values, 38 and 00. And I'm not sure exactly what the second one means. I mean, it looks like the first one is mapping pretty straightforwardly to the position of the crossfader. I'm thinking, could it be that this is like... that it's just for more precision? Because it looks like we're only getting 0, 0 and 4, 0 here. So that might suggest that this is like either 0.0 or 0.5, so to say. That would kind of make sense. Then that would mean that this control has a resolution of 8 bytes instead of 7 like most usual MIDI controls. Yeah, I'm gonna go with that as my theory. Coronilla on Discord is asking whether it might be for direction, but I don't think so because it's alternating between 0 and 4, 0. Also when I'm just like moving to the right, so I'm pretty sure it's just for one more bit of added resolution. And yeah, here's this automap feature that is always showing you the value is, I don't know, I guess it can be helpful sometimes. But yeah, I've written most of this down beforehand, obviously. So let's go to tab number 2, to Nocturne Protocol. Yeah, so except for the fact that for the speed dial you can also press it. So, okay, let me check what that was again. 5-1. Yeah, this document is a bit of a mess, but it contains all the information I care about. Okay, so once we've gotten this far, what can we do? Well, again, there's a bunch of stuff I've done already. But let's go to the browser just for a second. So yeah, if you want to write like a proper operating system driver that runs in the kernel, then that's obviously not something you can easily do cross-platform. And I did want to have something cross-platform, which is why instead I opted for libUSB. So this is a user space library for communicating with USB devices, and it works on Linux, macOS, Windows, etc. I don't actually know what etc. means here, maybe BSD? Oh, sorry, what platforms are supported? Here it is. So quite a few platforms. Not FreeBSD though, that's a shame. But yeah, for now I mainly care about these three, actually these two, Linux and macOS. Those are mainly what I use to make music. But of course, in terms of sharing this thing that I'm gonna write with other people, it's nice if people can use it on Windows as well. There was actually somebody in the TopLab Discord that told me they have exactly the same controller and exactly the same problem with Automap being obsolete. So they were also very interested to see what I come up with. Also, I was gonna post about my stream on Mastodon, but I forgot, so I'm just quickly gonna do that. If you'll excuse me. There we go. Yeah. So, libUSB is a C library, but I don't want to write C. It is, shall we say, not my favorite language. I write C++ at work, which is a bit better, but still uncomfortably close to C. So instead, whoops. Somehow I navigated to the GitHub and couldn't make it back. Okay. Instead of libUSB directly, I found this RUSB library for Rust, which is basically a safe wrapper around libUSB. Unfortunately, it does not have all of the functionality of libUSB, with one important example being asynchronous communication, because they're still figuring out how to adapt that API to the Rust model. But I think for what I'm doing, the synchronous stuff might be enough. And if not, there is actually another Rust USB library called NUSB, and this is like async from the start, and this is also pure Rust, so no C dependencies, and it sounds interesting, but I don't know, I wanted to try out RUSB or USB, or however you're supposed to pronounce that. RUSB. I like RUSB. Yeah. And it wasn't too hard to get started with, and I've actually done that, so now we can look at some of the code I have already. So I made a new Rust project, of course, and brought in the latest RUSB and also the USB IDs crate, which I'm not actually using right now, but it's useful for, you know, mapping USB device and, no, sorry, not device, but vendor and product IDs to actual names of those vendors and products. Okay, but so, oh yeah, also I called the project AutoCrap because it reflects my feelings about the whole automap situation. And also it's gonna be worse than automap in that it's not gonna do as much. It's just gonna be kind of a dumb interface to the MIDI data going in and out of the device. And well, I'm still thinking, do I want to add like the kind of basic stage tracking so that I would keep track of like encoder states rather than just sending the increment and decrement messages, just because with that kind of feature it's much easier to use it with a DAW, which I'm not that interested in, but other people might be, so it's something I'm keeping in mind as an option to possibly do. But yeah, so code. We have some basic imports. We have a type alias for my own result type. This is a common pattern in Rust error handling, where you make your own result type basically, which specifies what kind of errors it can return on a failure, and I've gone the really generic approach here of using a box of dynamic error, which means this can return as an error any kind of type that implements the standard error trait. And this is just because it's very easy to prototype stuff with this. I don't need to define separately every kind of error that might come out of my code. Then I'm defining a default timeout value of 1 second here. This is just because a lot of the functions in RUSB require you to specify a timeout, so I'm just giving this default one every time. Then I have this device spec type, because my idea is that although right now I'm only building this for the Nocturne controller, the Nocturne is actually not the only innovation controller that used automap. There are a few others, and I don't know, maybe other vendors have made them as well, I'm not sure. But I'm keeping the option open to implement, you know, device specs for each individual automap supporting controller and define how those get mapped to MIDI or OSC. But yeah, I don't actually have any of the other ones, so other people are probably gonna have to help me with that if they want support. Then I have this endpoint structure which defines a bunch of, or wraps a bunch of metadata for a USB endpoint. So maybe we can look at what exactly is an endpoint, because yeah, I've been looking at this USB Made Simple tutorial, and yeah, this chapter basically talks about the structure of a USB device, like logically. So you have configurations, you have interfaces and endpoints. And so a device can have a number of configurations, although it seems it's very common to just have one. For example, this controller just has one. And then each configuration has a configuration descriptor, which has some metadata about that configuration. Then it has some number of interfaces, and as they say here, each interface can have a number of endpoints and represents a functional unit belonging to a particular class. So I guess okay, well, here's an example, so I don't need to guess. A voice over IP phone might have one audio class interface with two endpoints for transferring audio in each direction, plus a human interface device interface with a single in-interrupt endpoint for a built-in keypad. Right. And yeah, I believe the Nocturne has just one interface, but it does have at least two endpoints. And if we go back to Wireshark, we can maybe see that. So the addresses here I think the way this address is structured, it's like I don't know what the first one is. I guess the second one might be the device index, and then the last one here is the endpoint. But I feel like the configuration should be here as well, somewhere on the interface. I'm not sure. But what I care about right now is that the endpoint is specified here. So we have endpoint 1, which is what is responsible for, I guess, reading all of the incoming MIDI, well, MIDI-ish data, and yeah, that comes in on endpoint 1, and then the outgoing data, for example here, and here goes out on endpoint 2. So we have endpoint 1 for input and endpoint 2 for output. And that's pretty much it. So yeah, that means also, wait, wrong Emacs. That means also that in my code I need to deal with two endpoints, reading from one and writing to the other. But yeah, this structure here is just basically the data you need to describe an endpoint, and it perhaps doesn't make sense to have the transfer type and direction here, because I believe those can be retrieved from the other info, but hey, whatever. And probably also the address, because I think this is like the triple you need to uniquely identify an endpoint, and then these you can get from the endpoint descriptor. But yeah. Okay, so our main function is just calling run, which is our main function but returning a result. Another common-ish Rust pattern, and it's unwrapping that result, so if we get an error, then it just crashes with that error for now. So the device spec defines the vendor ID, this is the one for innovation, and the product ID, this is the one for the Nocturne. Oh, hey, Nella. Then I'm not sure what I'm doing with controls endpoint config actually. The endpoint descriptor is part of the device descriptor response. Right, yeah, that makes sense. So you gotta scroll up to find that, yes. That does make sense. But yeah, as I said, I'm not too interested in that right now. I just want to go through this code in Wireshark, yeah. Hello, Hayes Anderson. I built MIDI controller, but I cheated with Arduino. Yeah, I've done something like that as well. But yeah, I guess you kinda need to solve the same problems, except you don't need to do as much reverse engineering there, because you can define the protocol that the Arduino communicates with the computer over. Okay, so the first thing I'm seeing here is that my code for getting the control in endpoint is probably wrong. Because this is using spec.controls endpoint config. And that is 2, but I think it should be 1 for the incoming data, so we'll need to refactor this somehow at a later time. Involved some circuit design and soldering, but very little code. Yeah, depending on the Arduino you have, you could probably set it up to send class compliant MIDI. I want to figure out hardware USB to MIDI in a way that makes sense to me. Not saying I'm gonna be able to build a USB host out of transistors, but also don't want to have to rely on a finished board. Yeah, that is, I think, that's gonna be beyond my current skill level, building a board for that. It is an interesting project though. To be honest, I would write an assembly, or at least try and see how far I get. I suspect mine is not class compliant, it is. Well, the way to know that is, do you need some kind of software on the end, like the computer end, to receive the data and convert it to MIDI? Or can you just plug it in and your DAW will see it? If it's the latter, then it's class compliant MIDI. Class compliant USB 1.1 MIDI open hardware op amp implementation. Yeah. I can't even begin to estimate how many op amps you would need to do that. I haven't tried testing on DAW, just other hardware. Okay, so it's like MIDI over 5-pin DIN, I suppose. Well, yeah, that's regular MIDI as well. It's not class compliant because that's a term that specifically applies to USB. But it does sound like it's actual MIDI. Unlike this innovation thing. But yeah. So, there's a bunch of, just getting some info here. Active configuration, product serial number. This thing doesn't actually have, or at least return a serial number. Then we configure the endpoint, which all that does right now is claim the interface so that no other kernel driver or software can access it. Because USB is like exclusive, so you can't have multiple things communicating with the same device. Thank you, I should have known that. Yeah, I guess that's about the class compliant thing. Yeah, I mean, it's a lot of standards and things to keep track of. USB is cool and interesting, but also a bit intimidating and spooky. I agree, and I mean, this is my first proper attempt at really digging into USB, so far it's not as intimidating as I feared, at least with this kind of relatively simple device. One thing that I learned that is interesting though is that when you plug in a USB device to the computer, well, the first thing that it does is it senses the USB version depending on the resistance across some pins, I forget how exactly. But then it does this reset of the device where the address of the device is set to 0, and at that point the device is basically accepting data going to any address, and I guess the kernel makes sure to set a real address to it before any data is sent out. But it's just interesting to me that there is this point where you could have a device getting data from basically any address, and it just feels sort of chaotic. But of course it makes sense because it is like a bus interface and everything is going over the same bus, so there needs to be an addressing mechanism, but yeah. Tend to eschew standards and opt for customs. Man in the middle attack. I'm not sure that's really relevant here. It's just this weird point in the USB initialization that these devices go through, and I mean, I suppose you could theoretically use that for some kind of attack if you were able to receive all the USB data going out from the kernel, but it seems pretty niche though, because first of all you're gonna need physical access to the computer to plug in your USB device, and yeah, I don't know what kind of what that kind of attack would look like in practice. Anyway, getting extremely sidetracked, but that's of course okay. So this code is like, it was originally one of the examples in the RASB repository, so there's a lot of unnecessary stuff here. Prob like a tree falling in a forest but nobody to hear it, is vulnerable but nobody can take advantage of that vulnerability. Yeah, I mean, it's not vulnerable if the kernel is taking care not to do anything else during that process, like making sure no data gets there. Also, that makes me think that with some devices, when you update their firmware, they recommend that you don't have any other USB devices plugged in while you're doing the firmware update. So I guess that might be related to this somehow, where it's like just to make sure that, well, there's some point where the device is accepting data to any kind of address, then it could mess up the firmware update if there's other data coming through. I don't know, but I suppose it's related to that. Okay, where is the actual interesting code that I've been doing? So yeah, as I was saying, this was originally an example from the RASB repo. There's a bunch of stuff here that I'm not using anymore, and I've just been like hacking on top of this. But yeah, so here I have this experiment send init function, and this is where I've basically replicated the initialization sequence sent by automap and tried to figure out what all the bytes stand for. So as I mentioned earlier, B0 seems to be a start byte. Then after that we have a reset command, and that's just 2 zeros, and that basically sets everything to 0, which has the effect of turning off all the LEDs, because with all the control values set to 0, that means that there's no LEDs to turn on. Then the second line is a total mystery to me. There's... like, I believe these are always in pairs, so it's setting something to 0, something else to 4A, something more to 0, something else to 3.5. And I don't know what these things beginning with 2 are, because I haven't found any controls in that number range. So yeah, no idea what this does. Not sure if it's actually necessary. Then we have the first intelligible line, so this is just setting knob 0 to 0, button 0 to 0. Something 0, but I suspect I actually made a mistake here when transcribing this. Okay, we can try this. So I'll turn off automap, clear this window, turn on automap again. And we see the initialization sequence. So I think it was this line. Yes. Okay, so this is supposed to be 4-1 and not 3-1, so I made a typo there when writing that. Because of course I wrote these down by hand instead of copy-pasting. And the descriptor? Well, yeah. Interesting thing here is that the first descriptor request is for a string descriptor and it gets a malformed packet, and that happens every time. So I don't know what's up with that. Then the second one, I forget what this is, but string descriptor, so that's oh yeah, we also have this which can help us figure out, so yes, that's actually what I used the first time. It's just a bit cramped here, so I don't see it properly, but okay, so this is telling us the language. That's what 03 means, and then the language ID is 09044 for US English. Yeah, you can scroll it. It's just awkward. I would like to have this line wrapped so that it's just 16, or like 8 bytes per line. But I wonder how you do that. Yeah, I mean, you can shrink it, but then it doesn't line wrap as I would like it to. Maybe there's some setting for that layout. Oh, but maybe we can use this kind of layout. Then it's better for this large font size. Yeah, this is good. So yeah, that's just telling us the language. I'm not sure what language means in the context of USB though, but anyhow, then here's where we get info about the configuration. And yeah, configuration. So I guess this is just telling us that there is a configuration number 1 and that's it. Then we get... Yeah, the first thing the controller sends is the position of the crossfader, so that's what we're getting here. And I guess it's sending that multiple times for some reason. Anyhow, so let's go back not to this Emacs but to this Emacs. Right, so I'm gonna fix this comment. This is setting knob 1. And the weird thing about this is that it sets the values of multiple controls multiple times. It might be that there's no particular like design reason for that, it's just an artifact of the internal state of the program. Also, other comment, you have 2 knob 6 currently. Oh, yes, thank you. Good eye. Then we have this very strange pattern. We're setting button 9, button 10, button 11, but then we're setting the speed dial. Yeah, not gonna worry about that too much, but yeah, so then we have this, which is interesting because this also looks like it would be setting knob number 8, but of course there is no knob number 8. So then it resets knob number 0 to 0C, which is 12, right? Yeah. Then another mystery value, and knob 1, and then etc. With this pattern you can see here. Then it sets button 8, 12, 13, 14, because that order makes a lot of sense. Then just button 15, which is the very last one, I suppose. Then 0, 1, 2, 3, all of the knobs in order, but first setting to 0 and then 0C again, for whatever reason. I think there's some kind of weird thing going on here where when the value of the MIDI control is 0, then it doesn't actually set the LED to 0, because 0 would be that there's no LEDs lit up, but here we always have a minimum of 1. So I guess the 0C is to set that. And then it does some kind of internal remapping between the actual value and the LED number. Okay, but yeah, I feel like we probably don't need to do all this, so I'm gonna copy this and try to write a minimal version, so we'll call it mini init. Actually, before I do that, let me just show you where it's actually called. So that's right after configuring the endpoint. Then I have some testing loops in here. So I made one to turn on the button LEDs in sequence, so maybe we can just take a quick look at how that works. For that I'll quit automap, which by the way, when it quits, it sends a reset, so all the lights turn off. That's good to keep in mind for our own driver as well. So yeah, this loop is just setting the value of each of the buttons so that only one of them is ever lit, and it's always incrementing the one that, like, which index is actually lit, and then it loops that and starts over at the end. So if I run that, we can see it working. What TikTok is telling me I'm inactive, which is interesting. I need to do this puzzle piece verification. Okay, there we go. Oh, and we have TikTok comments actually, but they are not showing up here, even though I made sure to do that. Like, I just updated the TikTok library for this. Oh yes, layout. True. Thank you. Okay, the TikTok chat is not working, or like the integration with my overlay, so I'm just gonna have to keep an eye on that manually. Where was I? Here. So yeah, here is the code I was showing. I've seen this controller on eBay a few times, been confused as to what it's actually supposed to be. Is it some kind of mixer? I mean, it's a generic controller, you could really do whatever you wanted with it. It works as a mixer, I suppose. It could be a DJ mixer because you've got the crossfader, and then you could have effects on some of the knobs. That's how I used it back in the day. Then Wokiapi asks, is the voice intentionally Dopplered? I don't know what that means. Is there some kind of audio issue on the TikTok side? I still have not figured out how to actually view the TikTok stream myself on my phone, because it doesn't show it for me because it's my own account. So I guess I would have to make another account to do that. But yeah, as we can see, the LEDs are working nicely. Now I'm gonna disable this part of the loop from the code. And let's try to send a more minimal init. Actually, let's keep this code here, so that we can see when the init is actually successful. So I'm gonna comment out a bunch of stuff here. Actually, I'm gonna comment out everything except the reset and see if that is enough to actually initialize the device. I do need to unplug it just to make sure we're starting off with a clean slate. Replug, and then rerun. Yeah, that does seem to work, at least to the extent that we get the LEDs working. Okay. So the infinite loop is not great for looking at data because it's gonna be sending data all the time. So I'm gonna make sure that only runs once, so we get one LED turning on, but then no more, and then we can look at other stuff. Rerun. Make each rotary control the brightness of the button LEDs. Unfortunately, I think the brightness is binary, so you have on and off. And I suppose you could do PWM, but I'm not sure if there's enough bandwidth to do that in a nice way, so that it actually works, the illusion there. Okay, why didn't this work? depends on if the board has itself has anything, yeah. Bandwidth on USB should be fine, but I don't know about update rate, because I mean, like, you only need like 80 Hz. Yeah, but right now I'm not getting anything close to 80 Hz, and it might be due to how I'm sending the messages. But because there's a bunch of overhead in each like interrupt, so I think I can send at least 4 messages per interrupt, although right now I'm sending only 1. So that could improve the situation, and then, yeah, I don't know. But for now, I'm not really interested in doing PWM. I did that in a previous stream for the kitties, and it's kind of it's a problem I've dealt with, so I'm not super interested in it right now. But yeah, this should have worked, but somehow didn't. I'll try setting this to 0. Okay, yeah. I think there was maybe some confusion with the breaks there, but oh, and also right, I am now manually setting this reset at the end because I wanted to test that out, but I don't want to do that. The chip should support that much logic, though shouldn't it? Probably not exposed with the current firmware, though. Yeah, that's the thing, I'm not looking at writing my own firmware at this point. Maybe in the future, waiting for my wire or pin grabbers to come from AliExpress to even have a chance of doing that. But also, I'm a bit afraid of doing it with my only Nocturne. If I had 2, then I wouldn't be afraid to potentially brick one of them, but or maybe not even brick, but like lose the original firmware, because I'm not sure if it's going to be possible to dump that. I did take a look at the datasheet for the microcontroller, and it does have a readout protection, so the question is whether there's any known way to bypass that. But yeah, don't think I need the sleep here. Okay, so now that I run this, it leaves on the first button LED, which serves as proof that it actually did something. And actually, let me unplug and replug one more time. Reset the Wireshark log. Run. Right, those are all the messages that I send. And now the question is, does it just send incoming data without doing anything special? No, it does not. So that's kind of interesting. That suggests that there is something we need to do in the initialization that sets that up. So just as an example, if instead of mini init, I run the regular init after replugging, kinda same, one of my STM32s probably needs repairs. Probably it's the spooky mystery lines. Yeah, that's my suspicion as well. Wait, but I'm not getting anything now either. Huh. That's interesting. Yeah, I guess I'll try another unplug, but... yes, it definitely does not send anything, like, right after unplug. I wonder if something happens when I close the device here. I'm just gonna add like a 5-minute sleep so it stays open. Yeah, it's not that either. As in, is this result maybe invalid because you didn't unplug before restarting? Well, I think I did, but now I definitely did, and it does not help. Let's see here. I wonder if we need to open the reading endpoint so that any data comes through at all. That would make sense, right? Because right now I'm just opening the writing endpoint, the number 2. For that, I think I wanna change this struct a bit, so we'll have in endpoint config and out endpoint config, and number 2 is out, number 1 is in. So it should be just a matter of adding another call to configure endpoint except not, because This just claims the interface, so I don't think it'll do anything different if we run it for both of them, because they have the same interface. At least as far as I understand this. We could try it though. Yeah, that didn't help. Right, so there's not like a separate opening of the endpoint, because the device handle is already open, so I guess we just need to like read from the endpoint. So let's make a loop to do that. That would go after this one. Okay, I need to look at RASB documentation. Read interrupt. Should really get some Rust documentation going inside Emacs, but I haven't written a lot of Rust, so haven't bothered to set that up yet. Result, or I guess that would be num_bytes. We'll put a try on there. The endpoint is gonna be control in endpoint. Wait, where's my thing? Okay, so it's the address that goes first, I think, like this. Then we want to allocate a buffer. So as far as I've seen, the most bytes we get at once is going to be 8.
I'd like you to meet our very charming little drummer.
So we should be fine with a buffer of size 8. Like so, and then take a mutable reference to that. And then we'll just put our default timeout. And I guess I don't need to split this across multiple lines. Then we can read. First we'll print the number of bytes and then the buffer. see how that works. Well, it doesn't. Alright, read interrupt is a method of handle. Oh, made a typo there. That should be all. Oh, my SSH password has expired, so I'm gonna need to type that. Just a moment. Oh, okay. We're hitting a timeout. Esko Pesonen asks on TikTok if I've swallowed a delay pedal, so that suggests to me that there is in fact something wrong with the audio. What about if I do this? Testing, is that any better? It does seem like I'm still getting audio in, but I don't know if there's delay. Okay, no more delay. Okay, thank you for letting me know. Yeah, I'm gonna assume that was TikTok only because I have to do a bit of a weird audio setup for TikTok Live Studio. Let me just get my windows arranged. There we go. Right, so this gave an error because it timed out, which makes sense because our default timeout is 1 second, and so if there's nothing coming in during that, then it'll time out. So instead of try, we want to do something else here. I guess we could have an if-let statement, but I need to look up the syntax for that. Okay, so it's if-let some num bytes equals the handle thing. Only then do we print that. So we just ignore timeouts. Although I'm actually ignoring all errors now, which is probably not great. Maybe it's okay for the time being. Mismatched types. because it's an OK and not a sum. Alright, now we can see data coming in. I would like to print these in hex actually, but I don't know how to do that. Oh, debug with hexadecimal integers, so we just add an X in there. Yes, that's better. Although, can we make it 0 padded? Zero 2. There we go. Yeah, that's much nicer. Okay, so I was wondering, why is it sending more bytes than I was seeing in Wireshark, but I think that's because, yeah, this buffer always has size 8, and I'm not really considering the num-bytes value here. So I think I can do something like this. Or not. I need to refresh my memory again on the syntax of Rust slices. Ah, okay, it's dot dot and not colon, like in Python. And then I need to take a ref to that. Yep, that looks more reasonable. And at this point, it's like we don't even need Wireshark anymore. So then next thing would be because I'm thinking how I want to structure this if I want to both send and receive data, which I need to do if I want to control the LEDs as well. And like the standard solution for that would be to use async methods, but as I said in the beginning of this stream, we don't have access to those in RUSP. So another option would be some kind of multi-threading setup where a separate thread will take care of writing and a separate one will read. But actually, maybe before that even, let's look at interfacing with OSC so that I'll have a reason to actually interpret the incoming data. So let's look for a Rust OSC library. And surprisingly enough, there's one called ROSC. I would never have guessed. Is this one maintained? So I don't know how complete it is. But the issues that are there don't look super big to me, so let's try this. And it'll install. And ideally, I want to support both MIDI and OSC and make both of those optional in terms of dependencies, so you can build with just OSC or just MIDI. But that's later. Okay, how does ROSC actually work? Let's look at some examples. We just want to send at the moment. Okay, so we need to deal with the UDP socket. And yeah, so this is relatively low level for an OSC library, but I guess that's fine. Let's import all of this stuff. And I guess it might be time to start thinking about command line arguments. Or maybe not quite yet. So let's do all of these things. I'm sorry for the noise, by the way. It's extra noisy here today because is very hot and my fans are running like kuin viimeistä päivää, as we would say in Finnish, which translates to like the last day. I think there's an equivalent-ish expression in English, but I don't know what it would be. Host address shall be just localhost to adder same. Also, let's not use unwrap because we are in a result context. We can just do try. So we have the socket. And this is basically how we're gonna send messages, I guess. So let's go into our little loop that is here. This is so messy, but I'm really like forcing myself to focus on getting stuff working before cleaning it up. Which is kind of uncharacteristic of me. I often end up spending a lot of time on making my code clean prematurely, and I don't know. There's advantages to that, but for now I just want to focus on getting stuff running. Minimum viable product or whatever. Okay, so we have right, here is where we need to actually interpret the messages. And I guess we should probably do that before even thinking about the OSC. So we're gonna have different types of controls. So we have knobs, or I guess I will call them encoders. We have the crossfader, and we have buttons. And we have the touches, but those are like associated with either encoders or faders, and I guess in theory on some controller they could be associated with buttons, so those are not like a separate control type. And also for some encoders, well, one in this case, we have the button press, low asks, and a dial. Well, I'm treating the speed dial here as another encoder because it is an encoder. It just has a special meaning in the context of automap. Then I guess we'll have different values for each control. gets a little complicated. So, okay, let's enumerate the kind of values that we have for each control. So for encoders, we have decrement, increment, touch, and possibly press, release. For the crossfader, we just have current value. For buttons, we have, oh, and also touch. For buttons, we have just press and release. And if I put my type theorist hat on, which I don't have an actual hat, but let's pretend I do, then it would make sense to encode these to be part of the types. But then also considering that we're gonna be sending OSC or MIDI, well, we can't really encode these properly in either of those, I think. Let's think about what these should be in terms of OSC. So we would have... we could put true here and false here. Or possibly 1 and 0, because I think OSC numbers are a bit better supported than booleans. This is gonna be a float between 0 and 1. Oh yeah, and touch is also like touch on or off. Wait. Like so. And we could say this is 1 and this is 0. This could be -1, this could be 1, 1, 0, 1, 0. So this is, in terms of numbers, all that we really need. Of course, we're gonna need some kind of way to distinguish, for example, an increment from touch on. In OSC, I would just do that with different OSC addresses. In MIDI, I guess I would do different CC numbers. But then if we're talking about CC numbers, then we kind of already have CC numbers, because we have the control numbers that are coming into, like, over the AutoMap protocol. So we could use those directly. Okay, so what we really have here is move, touch, and press, and those can have different values. Here we have move, which is just the current value, and touch. And here we have press. Maybe I'll call these down and up instead of press and release to not confuse with the umbrella category of a press, which can be either of these. Okay. So what I really want to write is a mapping from I guess it'll be I'm thinking about the crossfader because we have a higher resolution on that, so we might need to send that as 14-bit MIDI or something, but maybe I'll worry about that later. So in the simplest case, for everything else than the crossfader, we have a control number and a value, and we want to map that in the MIDI case to a control number and a value. In the OSC case to a string, which is the address, and a value, which is going to be a float probably. So now basically I want to define a structure with this kind of mapping. But then I wanted to also handle the possibility of having multiple of these pairs, because that's exactly what we get from the crossfader. We get 2 of these pairs. So okay, maybe it's a list in and list out type of situation. Right, so oh yeah, this is actually gonna be probably a byte string rather than a string. What is the typical Rust type for byte strings? Is it just array of bytes, or is there something else? Or maybe vec of bytes, that could work. Right, okay. But this struct is gonna own the string or byte string, so I guess we'll need to use a vec. Or, I mean, it could be an array, but this is more flexible, I suppose. And then value f32. Then, although I'm not dealing with MIDI yet, we are gonna have MIDI values eventually. And now it occurs to me that some controllers with this protocol might have keys as well, so there should maybe be support for note messages as well. You know what, I'm just not gonna bother with MIDI at this moment. Okay, so OSC value. Let's just comment this little bit of sketching out. Then I think hash map is what the Rust dictionary type is called. Let's import that. So we are gonna have a hash map. I wonder if there's like a... Oh yeah, here's the literal-ish way to construct one. So, let's start filling in our mappings. I guess it should be mappings and not controls. Okay. So, as the very first thing... Oh, I'm gonna give it a type. But then the question is, what type do I need here for the keys? Probably a vec, right? So the keys are vectors of pairs of bytes. Let's move knob 1 and actually this is not quite gonna work because for wait, it doesn't need to be a tuple or like a pair, it can just be the control number because we don't need to match against the value here. I don't know, I'm thinking like way ahead of what I'm trying to do here, but... Oh yeah, and we need a type for this as well. So this is gonna look like... Yeah, and ideally all of this should be user configurable, but not yet. Okay, so my problem is I'm trying to define this in a data-driven way, but there's gonna be a bunch of logic here that it's not clear to me yet how to make it like data-driven. So instead of doing that, I'm just gonna start writing code to match against the different controls. So the first thing we need to check is the first byte a B0. Well, I guess the first thing is to check if we even have that many bytes. if numbytes is 0, then we just continue, because there's nothing we can do with that. Okay, here we have at least 1 byte. We check if that's a B0. Actually, we check if it's not a B0, because in that case, we don't know what to do with this data. Actually, I guess we want at least 3 bytes to do anything useful with this, so let's just check that right away. Then we'll match bytes 1 against a variety of things. So for example, we're gonna have but this is also not that smart when we can just check if. Also, let me give a name to bytes 1. It's gonna be num, and just so I don't need to keep indexing. So if num is at least 0x40 and it's less than 48, then this is a knob. One of the regular ones, not the speed dial. And in this case, let me see how we actually construct OC messages again, because I deleted that. Oh, it's here. This is actually a string, not a byte string. I don't know if that makes sense, but it's fine. If we don't match anything, we're gonna continue. Okay, what is actually the type of that thing that we need to put in args? Let's look at the documentation. OSC type. Did we import that? Yes. So in this case, we could do something like... So there's two options for the OSC format that I'm thinking here. One is knob 0 followed by the value, let's say 1. The other one is the same, except everything goes to the address knob and then the number is passed as an argument. And I kind of keep going back and forth between which one of these I prefer. Because this one is nice to make right handler that handles all the knobs and then just does different things depending on the number. This one is nicer for defining separate handlers for each knob. But yeah, it's hard to decide. Maybe in the beautiful future where this is user configurable, the user is going to be able to select which one they want. Do both, yeah. Maybe not right now though, but it would be nice to have options. So I think for now I'm just gonna go with have like a Huffman coding that selects one of the two in the byte sequence. I'm not sure I understand how that would work. But I am just gonna do it this way for now. So that's gonna be the address, and then args is gonna be like how some postal codes don't exist. I don't remember how Huffman coding works, but yeah. Vec of OSC type, and here we're gonna do the float. Well, except that these are increment and decrement, so it kinda would make sense to do ints instead. But I vaguely remember that some OSC implementations actually don't implement ints, so maybe I'll just go with the float for now. It's like a software that I've had to use recently. I'm not sure if it's Super Collider, probably not, but something else. But yeah, floats it is. Hello Negvorsa, not sure what you're trying to convey with your emojis. Float, yeah, then what did we have? We have 0, 1 for increment and 7F for decrement. I feel like that is already 1 or -1 in like a signed 8-bit representation. Does Rust actually have signed 8-bit integers? Oh, not the game Rust. Oh yeah, I ate. So I could do the conversion there, or I could just say let's actually give this a name as well. It'll be val. If val equals 1, then it's just 1, otherwise it's -1. And now I think we should be able to do this and put our args here. And this, I think, is not quite ideal actually, because this is gonna allocate every time, but I will worry about that later. So this can just be a try. Maybe I will take this message out into a separate value, so we can print it. Okay, let's try that. And that did not compile. Oh yeah, we can't chain comparisons in Rust. Forgot my else. Okay, I'm calling this inbuf but referring to bytes. Maybe let's just call it bytes. Okay, try again. That method doesn't exist. Or is it because I don't have the trait in scope? That would make sense. Mismatched types. No, I guess this needs to be a string. And we need to put decimals here for floats. Okay, so for some reason parsing this address is failing. How does that make any sense? Oh, it needs a port as well. Right, okay. Let's go with 9900 and 9901. Okay, we have something, and okay, the message does not look quite correct because I want it to start from 0, so what I need to do here is subtract 40. Alright, we have OSC messages for knobs 0 through 7. Or we should have, so far we're just printing it, but let's see if we are actually getting them into, for example, Super Collider. So, okay, first of all, let's start up Super Collider. Then we're gonna want a OSC def. Oh yeah, and I need to specify the address, of course. Let's actually do this for all of the numbers. So we're gonna go... Is it like this? No, this is actually inclusive of the last value. So we're gonna loop through 0 to 7. We're gonna get that as an I. Indentation's not working right, but whatever. Something like this, but then we also need to put I in the name here. What am I missing? Oh, okay. Weird stuff going on with CEL. I'm not seeing those messages. Wait, I have a title running for some reason. Let's not have that. So yeah, it doesn't look like anything's coming in. Let's try to send to that address. Yeah, that works. So then the problem has to be on the Rust side, right? Let's try to run this again, maybe. That's weird. Maybe I can use Wireshark to see something about those messages. So if I go back into Super Collider, okay, I can't see that either. So these messages at least come through, although they don't get filtered by the OSC filter. I don't know how to use Wireshark filters. Esko Pesonen on TikTok asks about my favorite artists. Who are they? It's a good question and it changes quite often, but there are some artists that I keep coming back to, like even after years, and maybe the number one of those would be Solar Fields from Sweden. One of my favorites from the local Algorave-ish scene here is Alien, written as E-I-L-I-E-N. They make this kind of algorithmic dream pop kind of music. Okay, I think I got my answer. udp.tst port equals 9901. So if I now move the knob, there is not something like that. And follow-up question is whether I like the discography of 100 gecs, and yeah, they're alright. Like, I listen to them every once in a while, but it's not like my favorite music. Oh, now I understand what's wrong with this. Remember how I said earlier that I'm running this on a separate computer? Well, a separate computer sending to its own local host is a different thing. So, let's see here. Let's actually go with... Can I do this, I wonder? Okay, yeah, it does need to be the actual IP. You can't just put a thing like that. Okay, but now I wonder if I can just get that automatically somehow, but... Esko Pesonen says 100 gecs is, in their opinion, very rock and roll as music. And I mean, yeah, I agree. I was maybe a bit underwhelmed with the latest album, 10,000 gecs. Like, there's a couple tracks on there that I like, but otherwise it was like, I don't know. But 1000 gecs is pretty nice, I like that one. And also I feel like it's music where the novelty wears off quite fast and then it's not that interesting for me anymore, but yeah, every now and then, as I said. I liked a lot of Flora's solo stuff a bit more. Yeah, we actually talked about this at some point, I remember. And yeah, I like Haunted by Laureless a lot. And that one's, I think, better than pretty much all of the 100 gecs tracks. Esko Pesonen was first disappointed because it wasn't so electronic. I wonder if that's referring to 10,000 gecs or their music in general. But then says that they understood that the band can... I don't know how to translate this. Ammentaa aika paljon tollasesta peruskomastakin. Oh, about the second album? Okay. Yeah, I guess the translation would be that they are good also at making or getting something out of this more like basic music. not as electronic. Right, I was supposed to figure out the IP address of this computer. It's in 006. Okay. And now we are getting OSC into Super Collider. I'll just make the prints a little bit less verbose. All we really care about is the message here. Ooh, now I have lots of OSC devs running because I forgot to convert this to a symbol. Okay, so now we are getting either 1 or -1, depending on which way I turn the knob. And it's interesting because there's like these ticks that you can feel on the knobs, but one tick is actually 2 messages. But if I just turn it like part way, then I get 1 message. Interesting. So they are more precise than you might guess from the physical feeling. Okay, that's knobs. What about buttons? Or actually, before buttons, let's do the touch events because those are fun. So for those we have numbers of 60 through 66, but I think it's supposed to be 67 and one of these is just broken. So I'll put that as the upper bound. And now I'm gonna call this knob touch. And that's gonna be in this case we have 7F for pressed, and then otherwise we want 0. I like this part of programming where it starts to get very quick to implement things. Okay, yeah, so we're sending those, but we're not reading them in Super Collider. So I'll just make a separate OSC def. So yeah, now we're getting the touch events, and this is really cool. We could already start to build some kind of instrument with this. You know, why don't I take a break from the Rust stuff and actually do that? So let's make a nodes array. That'll be nil times 7. Take the value. And can have separate handling for if it's press or release. So what we'll do is if there is something in nodes at that index, then we free that. And then we just set that to nil. That's when we're releasing the touch. Actually, I guess we want to do this in either case, so let's just put it here. And then we'll make a new node. Let's go with pulse wave for now. And I guess we could use some kind of scale. That's a good one. Dorian is one of my favorites. And then I need to look up how degree to frequency actually works, because I do not remember. Degree, root frequency, and octave. Okay. So our degree is gonna be just I. Root frequency. Well, I guess we can do what the example does, which is 60 midi CPS. And octave, I don't know, 3. So now if I run this, it won't compile. Why is that? Also, we should have an envelope on this maybe, but I don't care right now. What do you mean unexpected binary operator? Let me break this up a level. I'm so confused. Oh, here. Okay. Okay, now I should be able to play the touch sensors. Except I don't have the superglider server running. Okay, try that again. And there is nothing. I think I must have messed up the math here somehow. Seems like we're not even making it into this block here. Oh, because val is supposed to be element 1 of message. Okay, that's harsh. Turn down the volume, decrease the octa a little. Yeah, it works. It's not perfect. I noticed the first one doesn't always register reliably. Yeah, amazing. Yeah, I have to say it's not the best feeling instrument in terms of physical touch. The knobs are quite small and but yeah, it does work as a proof of concept. First and last being unreliable / broken does point at trace layout. The point is still turning the knob. Yeah, maybe. But it could also just have broken from the years of use that I did get out of this at one time. Oh, it's actually not just the first one. Maybe there's like a spot on my finger that's less conductive or something. I don't know. Okay, yeah, but the first one is like particularly bad. Anyway, yeah, that is touch for the knobs. Then what else do we have? we have buttons. And those start at 7-0 and go all the way up to 7F. I guess we can pretty much copy this. In order of touch, so the first one you touch turns mod 1, etc. But there could be something like, if I'm touching knob 1, then knob 2 does something else than it normally would. Or something like that, to get like more knobs out of this thing. And of course you can do that with regular buttons as well, but it's much lighter to just keep your finger on the knob. Or you could do the same with the crossfader, which I believe is also supposed to have touch sensing, but I don't see it right now. Oh yeah, it does. Wait, what? Okay, this is interesting. The crossfader has touch sensing at like the very beginning and end of the range, but otherwise it doesn't. That's pretty weird, but it is the same number in both cases. Touch dub, DAW style. What is touch dub? Wow, I'm surprised by this. I never knew it's actually just at the ends of the range. Oh, that does seem like they did add that as like hardware solution. In those you can select the override style of new events. Oh, like you mean overdub. Yeah, that kind of thing, sure. Yeah, lots of things you could do with this. Ah, okay, so latch is as soon as you change something it records, and stop until stop, and touch is while you touch. Right. Yeah. I don't know if, or to what extent that like applies to my Super Collider live performance scenario, but so you can disarm the channel after stop touch. Yeah, that makes sense. But I'm just gonna put the buttons here, which is again a very quick job, which makes it a 0 on after touch, I guess. Yeah, buttons, so Now we have buttons all the way to 15. And I'm not gonna bother testing it in Super Collider because at this point I trust that the messages are getting there. Okay, then we have well, the speed dial, I guess, as well as its associated button. So in this case it's just num equals 4a, and then we do the same thing as before for the knobs. And here we don't even need the number. Oh yeah, I need to turn this into a string rather than a string reference. Okay, we have that. Then speed dial button. Which was 5-1. And for that we're just gonna use this code. I don't know how useful these comments are given that we can see the control from the address here, but I'm doing them anyway. Then we have the crossfader touch. '53. And finally, the actual crossfader. So this is, I guess, the most difficult, so to speak, case of all of these. Wait, what am I doing? Something weird. So that's gonna be 48. Oh, I have some sort of weird typo here. see what I did wrong. I'm just gonna copy paste this again. That's better. Okay, num for 8. And actually I wanted this right here. So in this case we actually need more elements. We want to check that we have at least 6. Then we want to define num2, which is gonna be bytes index 4, as well as val2, which is bytes index 5. So in this case, we are just gonna take fill in this boilerplate first, X fader, and then the actual val goes here. So what is our val? So if we have val from 0 to 127, I guess we'll shift that 1 bit to the right, to the left, sorry. Then add the 1 additional byte from val2, which can be either 40 or 00. I'll just check if it's not 0. Kind of abusing my naming scheme here, but this is gonna be the 8-bit value that we get. And once we have that, I guess we just need to divide that by 255. Cannot divide you 8 by float. Okay, I need to cast it. Alright. So we are getting crossfader values and they look reasonable to me. No, wait, they go up to half. Oh, also music. What did I do wrong? So if we have val equals 7f, that's this in bytes, right? So then Ball shifted 1 to the left is gonna be this. And then if we OR that with either 1 or 0, we should get a value between 0 and 255, right? What am I missing? Okay, let's add some debug prints. Oh. Okay. So we do get a value from 0 to 255. Oh, I'm supposed to use val h here. Of course. So now we can see that it indeed goes from 0 to 1. Cool, that is pretty much all of the input, I think. Which would make the next question how to handle output. But I've been at this for 3 hours now, and I think it might be time to take a break, get some food, and probably take a shower because I'm really sweating in this temperature. According to my computer thermometer, it's 30 degrees here in this room, so yeah. But we made good progress. Thanks everyone who joined in the chat. Thanks Nele for helping me debug and correcting some of my notes. Yeah, it is warm. I mean, this house is in general very warm. It's only, I think, 20 outside, but this house is warm, and then also me having 2 computers on makes it extra warm. So yeah, that's just what I live with. I do have a fan here blowing all the time, so that makes it a bit easier. And possibly also warms up the space even further, but at least it feels a little colder with the airflow going on. And that is also part of the noise you hear. And then there's computer fans, and yeah. But anyway, that's gonna be it. Thank you everyone for joining today. I'm not sure if I'm gonna stream the rest of this work because there's not that much left. So I might just do it on my own and then probably publish this on GitHub at some point. Once I feel it's production ready, so to speak. So yeah. Thank you, like, follow, subscribe, press all the buttons. I'm used to saying good night, but it's not night yet, so I don't know. Happy Pride and have a good rest of your day. Bye bye.